What happens to a wind turbine blade when it dies? They're the size of a football field, made from indestructible fiberglass, and they're piling up. 800,000 tons of blades end up in landfills each year. By 2050, that'll be over 2 million tons just in the US. But in an industrial shredder in Iowa, they're being fed into a giant crusher and ground down into the very cement that makes our buildings. This is the blade crusher, and it's solving renewable energy's dirtiest secret. Wind turbines generate clean energy, but their blades, built to last forever, are clogging landfills at a staggering rate. In Fairfax, Iowa, one machine is turning these giants into the cement beneath our cities. It's a breakthrough, but it's also a race against time because the biggest wave of blade retirements is yet to come. To understand the race, you have to understand the blade itself. A single wind turbine blade stretches longer than a Boeing 747 wing. Its skin is a composite, fiberglass threads locked in epoxy resin, baked under pressure until it's harder than a ship's hull. About 70% of the blade is silica, the same mineral as sand. The rest is plastics and balsa. That recipe is a miracle of engineering. Light enough to spin, tough enough to survive hurricanes. But the very quality that makes blades perfect for harvesting wind also makes them almost impossible to destroy. They don't rot. They don't rust. When buried in a landfill, they sit there for centuries. And they're being buried right now. In the United States alone, 8,000 blades were pulled down in 2021. Turbines are designed for a 20-year life, and the first big wave of installations from the early 2000s is hitting end of life all at once. Every year, about 2.4% of the global blade fleet must be retired. That's an estimated 800,000 tons of blade waste annually, enough to fill the Empire State Building's volume several times over. By 2050, the US will face over 2 million tons of this material, all of it resisting decay. Most of it ends up in the ground. Materials engineer Claire Barlow of the University of Cambridge calls the situation inconsistent. Wind turbines are the symbol of green energy, yet retiring the blades in landfills undercuts the entire promise. There's an irony that clean power's biggest physical footprint is silent, toxic, and permanent. Governments saw this coming. The European wind industry has set a January 2026 landfill ban. That means every blade removed from a European field must be recycled or reused. The pressure is on, and the race is to find a process that can handle the incoming megatons of fiber-reinforced plastic before the ban hits. That's where the cement connection becomes critical. Because silica, the very skeleton of a blade, is exactly what cement kilns crave. In Fairfax, Iowa, a facility run by Regen Fiber, a subsidiary of Alliant Energy's Trevero division, has commercialized a mechanical answer. They don't incinerate the blades. They don't chemically dissolve them. They crush them. And what emerges from the grinding chamber doesn't look like a blade at all. It looks like gray powder and fibrous fluff, destined to replace virgin rock in construction. But to grasp what happens inside that crusher, we need to see the blade's final journey. From a prairie wind farm, loaded onto an 18-wheeler, to the throat of a machine that can shred a Boeing wing in seconds. That machine is called the 95DK, and it's about to define the future of renewable waste. The blade arrives on a flatbed trailer, escorted by pilot cars because it's 170 feet long and weighs over 10 tons. At the Regen Fiber facility, the crane lifts it gently. This isn't demolition yet, it's surgery. The blade is placed onto a conveyor that feeds directly into the 95DK, a machine whose name sounds like a weapon because it is one. The 95DK's twin shaft cutting system generates monstrous torque. It doesn't slice with high-speed blades that would overheat. It grinds with interlocking hooks that pull the composite apart. Fiberglass and epoxy scream, then surrender. The first stage reduces the blade to hand-sized chunks. Those chunks go through secondary grinders, then screens, then classifiers. What pours out the other end is a stream of raw, crushed wind turbine blade material. Researchers call it RCWTB. It's a gritty gray powder laced with shards of glass fiber and flecks of balsa wood. To a cement plant, That powder is a replacement for sand, limestone, and clay, the very minerals that must be mined from the earth. But here's what's astonishing. The blade's plastic resin also contains energy. In a cement kiln, at temperatures above 1400 degrees Celsius, the resin burns as fuel while the silica becomes part of the clinker. G estimates that using blade material as a partial coal substitute cuts carbon emissions by up to 27%. You read that right. The blade that once spun in the wind not only makes the cement, it fuels the fire. Regen Fiber can process 30,000 tons of blades per year, roughly 3,000 individual blades. And they're not alone. Across Europe, cement co-processing has become the default destiny for blade waste, because kilns can absorb the fiberglass without choking on it. It's the only route that's truly ready at megaton scale, rated TRL 9, fully commercial. But there is another path, one that promises to embed the blade even more directly into our built world, grinding it so fine that it replaces the aggregate in concrete itself. Here's where the science gets strange. When Spanish researchers took the 0 to 32 millimeter fraction of crushed blade and used it as an aggregate substitute in mortar, the results were extraordinary. Porosity dropped by over 23%. Flexural strength jumped by 36.5%. The toughness index, how much energy the material absorbs before cracking, improved by nearly 250%. The knife-edge fibers of glass act like internal rebar, bridging microcracks that would normally spread. The blade was not just disappearing into concrete, it was actually making the concrete better. But there is a catch. Replacing natural sand and gravel with shredded composite isn't as simple as swapping ingredients. The fibers make the mix thirsty. Water demand goes up, workability goes down, and if the glass chemistry isn't perfect, you risk an alkali-silica reaction that can slowly eat the concrete from within. Every batch must be engineered with the care of a pharmaceutical. And even when the recipe works, the economics have to survive the real world. The powder that comes out of the crusher must compete with virgin aggregate, which is among the cheapest commodities on the planet. Sand and gravel sell for a few dollars a ton. Transport a giant blade from a remote wind farm in Oklahoma to a processor in Iowa, and the trucking cost alone can kill the margin before you've sold a single pound of powder. Many blade owners look at those numbers and choose the landfill. $10,000 to bury the problem versus 3 times that to recycle it. So, a paradox emerges. The machine can do it. The chemistry works. The cement industry is willing. But between the factory gate and the landfill sits a brutal accounting reality. The blade crusher has solved a technical problem. It has not yet solved a market one. And that gap is exactly where the coming tsunami of waste will hit. Because while we debate dollars and cents, 800,000 tons of blades are being made every year that will demand retirement 20 years from now. The race isn't just to build better crushers. It's to make the powder profitable before the wave breaks. That race is being run in laboratories and boardrooms right now, and only one side can win. That race is being run in laboratories and boardrooms right now, and only one side can win. But here's the twist. The blade crusher is just one machine in a quiet global war over how to dispose of renewable energy skeletons. And the consequences are bigger than anyone imagined. Because while the grinders are chewing through blades in Iowa, a second path is emerging that could make grinding obsolete or make it even more essential. Carbon Rivers, a company born out of advanced material research, has commercialized a process called pyrolysis. They heat shredded blade material in the absence of oxygen, breaking the epoxy resin into gas and oil that can fuel the reactor itself, leaving behind glass fibers that are clean, intact, and retain 90% of their original strength. That's not waste, that's a raw material. Those recovered fibers can go into new car parts, boats, even new turbine blades. This isn't just recycling, it's chemical unmaking, and it promises true circularity in a way that crushing into cement filler never can. Washington State University researchers backed the science. The recovered glass threads are nearly as strong as virgin fiber, and the energy payback makes it commercially viable. If this scales, the blade doesn't end up as a silent ingredient in concrete. It gets reborn as the next generation of durable goods. But there's a third path, and it's so simple, it's almost absurd. Don't destroy the blade at all. Across Europe, you can already see bridges made from intact blade sections, playgrounds with slides carved from blade skins, sound barriers along highways, bicycle shelters, even architectural canopies. The blade is already engineered to bear hurricane loads, so why not let it bear a roof? Designers have turned decommissioned blades into affordable housing modules in disaster-prone regions, where the indestructible composite becomes a shield against storms. This is direct reuse, and it avoids nearly all the processing costs. The problem? The supply of creative architects and willing municipalities is tiny compared to the avalanche of blades. You can't build enough playgrounds to absorb 800,000 tons of waste per year. And that's where the numbers turn from alarming to terrifying. Regen Fiber's facility can handle 30,000 tons annually, roughly 3,000 blades. But that's just 3.75% of the yearly U.S. decommissioning total. Cement co-processing in European kilns can swallow more, but it's geographically constrained. You can't economically truck a 50-meter blade from a Wyoming ridge to a kiln in Germany. The vast majority of today's blades still make a one-way trip to the landfill, where burial costs $10,000 versus the $30,000 or more to recycle. The recyclate they produce, glass powder, short fibers, must then compete with virgin sand and calcium carbonate, which sell for a handful of dollars per ton. The economics are so punishing that even the most environmentally committed operators sometimes choose the hole in the ground. Yet the world is about to make that choice illegal. The European wind industry's January 2026 landfill ban is not a suggestion. It's a hard deadline. Every blade removed from an EU field after that date must be recycled or reused. That means the continent needs processing capacity for its own impending blade wave, and it's building it. New partnerships are forming between turbine manufacturers, waste processors, and cement giants. Holcim and GE are already feeding blade silica into their kilns. Wind Europe's Circularity Hub tracks every known reuse project, from noise barriers in Denmark to bus shelters in the Netherlands. The continent is treating the ban not as a burden, but as a launchpad for a new industrial sector. In the United States, however, there is no federal ban. The regulatory pressure is absent, leaving the economics alone to drive decisions. And the economics right now point straight to the dump. This asymmetry sets up the most dangerous imbalance in the whole story. Europe will innovate and industrialize recycling because it must. The US, without a mandate, may fall further behind, creating a two-tier system where the blades piling up in landfills represent a deferred environmental debt that someone will eventually have to pay. Meanwhile, China, India, and South America are building wind farms at breakneck speed with no blade retirement plans at all. The global wave is not just coming, it's already cresting. And we are collectively pretending the water is still ankle-deep when it's rising above our waists. What's coming is a material reckoning, and the question is no longer whether we can crush a blade into cement. We've proven that. The real question is whether we can build an entire global system fast enough to catch every single blade before it touches the ground. The answer to that question is being written right now, in a machine shed in Fairfax, in a pyrolysis reactor in Tennessee, and in the conference rooms where landfill companies are still the cheapest bidder. And that answer is being written right now, not in a lab, but in the dust and noise of a facility where a single machine processes 3,000 blades a year into powder that flows into concrete trucks by the ton. The blade crusher has proven the concept. The silica locked inside a blade is purer than mined sand. The fiberglass fibers act as internal reinforcement, and the resin burns hot enough to cut coal use in a cement kiln by up to 27%. That's not just disposal, that's symbiosis. The wind industry's biggest liability becomes a raw material for the built world, and the built world's most carbon-intensive manufacturing process gets cleaner in the bargain. The blade that's spun in the air for 20 years now holds up a bridge, silences a highway, or becomes the floor beneath your feet. The numbers bear this out. In Spain, concrete made with crushed blade aggregate showed a 36% jump in flexural strength and nearly 250% higher toughness. Researchers call the effect micro-rebar. The glass shards bridge cracks at the microscopic level, arresting failure before it spreads. What was feared as contamination is now being engineered as improvement. In Denmark, a playground slide is made from a blade's curved tip. In the Netherlands, a bicycle shelter stands under a canopy of recycled blade skin, its original aerodynamic form now shedding rain instead of wind. These are not experiments anymore. They are infrastructure. But the true scale of the transformation is measured in kilns. Cement coprocessing has absorbed thousands of tons of blade waste across Europe. Holcim, one of the world's largest cement producers, feeds ground blade into its precalciners alongside limestone. The heat of the kiln, over 1400 degrees Celsius, vaporizes the plastic resin into energy, while the silica melts into clinker, indistinguishable from the rock it replaced. No waste ash, no toxic residue, just cement. And because the blade's resin replaces some of the coal, the kiln's carbon footprint shrinks. In a single run, a cement plant can consume the equivalent of 200 blades, producing enough concrete to build a 30-story tower. The irony is complete. The very industry that anchored wind turbines to the earth is now consuming the turbines themselves. Yet the most surprising detail isn't the chemistry or the engineering. It's the pace. 5 years ago, nearly every decommissioned blade in the world went to a landfill. Today, the largest handling pathways, mechanical grinding, cement coprocessing, pyrolysis, are commercial and scaling. The European landfill ban forced the door open, but the market is now pulling it wider. Blade material is no longer a disposal cost. It's a traded commodity. Regen Fiber's output supplies manufacturers as a substitute for virgin filler. Carbon River's recovered glass fiber goes into new automotive parts. The waste stream has become a supply chain, and the blade crusher sits at its pivot point. That pivot matters because the next wave of retirements is not a decade away. It's already here. The early 2000s boom built tens of thousands of turbines, and each one is now reaching its end. The choice is no longer abstract. Either we process blades into value, or we bury the promise of green energy under a mountain of composite. The machine shed in Fairfax, the pyrolysis reactor in Tennessee, the kiln in Germany, these are the front lines. And the fight is not about whether the blade crusher works. It's about whether we deploy it fast enough to catch every single blade before it falls. Because the blade crusher isn't just a machine. It's a test of whether the industries that promised us a cleaner future can clean up after themselves. The wind turbine is a symbol of green energy, but the pile of retired blades behind it tells a harder truth. No technology is waste-free. The question isn't whether we can recycle, but whether we choose to. The blade crusher can grind a Boeing wing into dust. The kilns can bake that dust into bridges. The reactors can unmake it into new fiber. But every day a blade still reaches a landfill. We're borrowing against a future that will ask why we didn't move faster. The answer is being written now. In policy, in profit margins, in the quiet hum of a grinder in Iowa. If this story opened your eyes, share it. Hit subscribe so you don't miss what comes next. And next time you walk on a sidewalk, remember, part of it might have once caught the wind.